if you haven't noticed, I've got a 3D engine right here. This is my 3D engine that I use, that I have made. This is my 2D engine that, of course, I've made and that I use. Because I use two different engines, one for 3D, one for 2D, just so there's not as much data being passed. And I've got a C3 Effects IDE that I built for Construct 3, which is a completely different 2D engine, was not built by me, but I built it to help people make effects or new shaders for that engine. So if you ever see anything open over here, it's because like my import settings or something is messed up, so I just kind of cheat and go over there and look and see what exactly I'm messing up, because I normally don't do videos, but it's something that I wanted to do and something that I'm still learning, something that I'll get better at in the future, but we will see. So next we need to create a shader class. Now, normally you see people use shader programs. We are not going to be using a shader program. We are going to actually just build everything into the shader class. That way we have no extra classes that is basically just not doing anything special that could have just been put into another class. So whenever you create a shader, it's all going to be done into this one class. Okay, so we're going to be needing to access the Vertex shader and the Fragment shader. So first we need the program, and then we need the Vertex shader, and then we need the Fragment shader. And if you're ever wondering why these are ints, is because they're basically like pointers. They point to where the information is stored on the computer. So let's go ahead and create the constructor. We're going to pass in a file name. So anytime we create a shader, we're going to be passing in the file name, and we're actually going to be uh, importing it using it and a custom folder that we will create here in just a little bit. So program equals gl create program, and once again I've got some importing things I need to take care of. So we're going to say the vertex shader equals gl create shader. I'm using a gl vertex shader, and then we need the shader source. So shader source, going to pass in the vertex shader, and we're going to be using a create shader function. This will be uh, something that we will be doing here in just a minute as well, kind of like on the mesh. And it's going to end in .vs. So we're going to end our file names in VS or FS. So VS obviously is our vertex shader, FS is our fragment shader. Honestly, if we wanted to, we could put the vertex and the fragment inside of the same file, kind of like how Unity does theirs as well, but maybe later on we will do that. But at first, we're not even going to mess with that. But later on, that is an option. So we'll see how that comes along. So after that, we need to compile the Vertex shader. And then we need to check the status of it. So we need to do if GL get shader I vs to get the compile status does not equal 1. That means if the shader was not compiled, then we need to throw an error and we're going to exit the program. So we need to do system.error.println gl get shader info log, and then pass in the Vertex shader. And then we're going to exit the program. Let's see. Nope, it's not letting me do any of those. God, I really need to fix that. That is extremely annoying. Now we need to do basically the same thing for Fragment Shader. The only thing is we need to change this to a Fragment Shader instead of a Vertex Shader. Do GL shader source fs create shader, and then we're going to once again pass in the same file name because our Vertex shader and Fragment shader is just going to use the same names, just different file extensions. And then we're going to compile the Fragment shader, and then once again check for errors. GL get shader I. Did I? No, I did not. Oh, yes, I did. Okay. Just making sure. I thought I screwed up yet again. Need to get the status. Does not equal 1. And then we're going to do the exact same thing, which I don't know why I just didn't do this in the first place. And then we're going to just pass in the Fragment shader. Then we need to attach them, since now we've got the Vertex shader all set up, the Fragment shader. Now we need to attach it to the program so that whenever we use the program, it'll use both of these shaders. So then we're going to do GL attach shader. I'm going to pass in the program and pass in the Vertex shader. And do the same thing for the Fragment shader. And that will attach both of those. And then we need to bind the attributes. So, like how we discussed earlier, the vertices we passed in as 0 and UVs we're passing in as 1. So we're going to bind the trib location, pass in the program. We're at 0 because we're going to do vertices. And then we're going to do the exact same thing for the these in slot 1. Alright, so now that we've gotten that done, now we can link the programs and we can validate the program. So we'll do GL link program, and then we're going to pass in the program. Then we could check the compile status for the program, because here we're checking the compile status of the Vertex shader. Here we're checking the compile status of the Fragment shader. Now it's time for the program itself. So GL get program I, pass in the program, do GL underscore, link underscore status does not equal 1. And then we're going to do an error print and GL get program info log and pass in the program. And that will print any error that we have, so it'll tell us exactly what's going on. And then, of course, exit just like we did before. And then after we link the program, now I'm going to validate the program. And just like linking, it also can be checked if there's any errors. I'm going to pass in GL validate status instead. So if it does not equal 1, do the error, and then we're going to use GL get program info log program. So it's the exact same thing as before. Okay. And then system.exit 1. So the exact same thing, just here we're using validate status, there we're using link status. And that is it for the constructor. Now we need to actually create the create shader class. And so for that we are going to use private string create shader, and then file name for the shader. And then we're going to need a string builder. We'll call it sv equals new string builder. And get a buffered reader in here. Maybe. I'm going to use a try catch statement. So what a try catch is, I mean, probably should know this already, is it tries it out, see if it's going to work. If it does not work, then it throws an exception. whenever it throws an exception, we want to print that stack trace so that we know what's going on. So e dot print stack trace. And then just go ahead and add the return statement. So return sb.toString. Import buffered reader. Unreachable block of code. Oh, screw you. Okay, so now I'm going to do br equals new buffered reader, new file reader, new file. We're going to use a resources folder that we're going to create here in just a few. Inside of that resources folder, it's going to be a shaders folder. That way we can make it a little neater in there. I'm going to say plus the file name, 2, 3. Import file reader. There we go. Oh, need file. Oh, all right. So that is going to do all that. So then we need cache string, which is going to be the line that we're currently reading. So I'm going to say while the line equals br dot read line does not equal null. What? Oh. So I didn't encase it. There we go. So while there is something, or while this line is not null, so it reads the line, stores it, and then it checks to see if that line is null or not. So if it is not null, then we're going to append the line. So I'm going to do sb dot append line, and then se append put in the return. And we are going to close the buffered reader. And outside of all this crap, then the shader class is done. And once again, I will check my imports, which I think it is all GL20 actually, so this actually might not be a pain in the butt. Well, let's try this out. So, import static org.library.game library .opengl dot GL20. All right, there we go. Change that to an underscore. GL compile shader. What did I just spell that wrong or something? Yes, I did. Gotta change that to a capital S. See, whenever we fix our imports, then we don't have to worry about that stuff. Uh, After this episode, I will check my imports and see what in the world's going on, and then it'll automatically uh, finish whatever is on there, so we don't have to worry about stupid little things like that. So our shader class is done, our mesh class is done, so now we need to create a folder that will hold our resources. So inside of our resources folder, we will have a shaders folder. Now we can create the shaders themselves. So I believe I have this open already. So go to the resources folder, go to the shaders folder, create a new text document, and I'm going to call this def yeah, whatever. If we need to change that later, I'll do that. No. No, I... Aw, you pain. Default shader. And vertex shader. Yes. Create another file. Name it the exact same thing, except for this one is .vs for Fragment Shader. Yes, Fragment Shader. And go into right here, and we're going to refresh it. And there they are, right there. So now that we created the files, now we can actually type in the shader code. Which the shader code is going to be very simple for now. The only things we're really going to be doing is passing in the colors. That's really about it. Next episode we will work on the orthographic projection for the matrices. So we will create a matrix class and all that fun stuff, but right now we're just going to put something onto the screen just to have something to look at. And I am going to be using version 140. You may not be able to. You can check which version that you're going to use. I have disabled my graphics card because what I'm doing currently outside of this project, I do not want that graphics card to be enabled. So I currently have it disabled, so I am using 140. I can't remember exactly what version I was using with my graphics card, but if you can't get it going, just type something in the comment. I'll take a look at my other programs and see exactly which version I'm using. So first thing we need to do is we called this position. We're going to be using a vector 2. This is the position of the vertices. And we're always going to do this first. So second, we need texture chords, because that is what we called it. And I don't think we really need normals because everything's always going to be facing the screen. We will, though, pass in the color. So I'll do a uniform vector 4 because color has 4 values. We'll call that matte color. And then we're going to need to output that color to the fragment shader. So out vector 4 color. So every shader will start just like this. So in order to set the position or tell the computer how to render it, you're going to be using GL position. This is something that you'll come quite familiar with if you've ever messed with shaders. And it's extremely simple. So all it is GL position equals vector 4 because you need 4 values to actually pass into it. So since we're only using 2, I'm going to call position. We want the Z value to be 0. I'm going to pass in 1. And that's it. That's how you set the positions and how it's used. It's very simple. And then all we have to do is pass the color over to our fragment shader. So I have this opening up in Notepad for some odd reason. So we'll just go over to that then. And Fragment Shader is just extremely easy. Do the version stuff again. And we need our out color. So this is the color that we're going to be passing. And then this is the color that we are inputting. So it's the same variable name, out vec4 color, in vec4 color. So this is what you're outputting, this is what you're inputting. And then just like before, I'm going to use the main function. And it's really easy. Let me show you just how hard this is. Out color equals color. That's it. So you're just passing this color to this, and then the fragment shader is outputting the color. Super simple, super easy. Now, one thing that we do not have yet, we've got it set up because we created the mesh class, but we need to create vertices for the quad that we're going to be using, which is a little bit tedious, but stuff that you have to do. And then we need the information for the UVs. So let's go into core. And let's see here. How do I want to do this? I'm going to create it up here. And I'll do float array of verts equals new float array. And we're going to create them right here. I have them jotted down so it's going to be a lot easier. So we're going to do negative 0.5f. So this is your x, this is your y. So what we're going to do is we're going to start up in the top left corner. since the first thing we're going to be doing is UI, we're going to have everything set to the top left corner. And so that's how I want to create my mesh for the UI, is the top left. So after the top left, then we need the top right. I'm going to do 0 0.5, 0 0.5. And then the bottom left, which would be negative 0.5f. Now, this is our first triangle, starting from over here, going to over here, and then down to, what corner do I have it on? Oh, I do have it over here, don't I? Okay, so it's going to go from here, over here, over here. Now we're going to start from right over here, go to the lower left, so lower right, then lower left, then upper left. So we're going to do that, and then negative 0.5 f, negative 0.5 f, and then negative 0.5 f, 0.5 f. And there we go. That is the vertices setup, so that we can pass in to the mesh that we create. Now we're going to move on to the UVs. It's going to be just like this. All right. So this is going to be a little shorter. So we're going to start with 0. And go 0, 1, not 10. So 0, 0, 1, 0. Let's see where I got here. 1, 1, 1, 1, 0, 1, 0, 0. So 1, 2, 1, 2, 1, 2, 2, 1, 2, 1, 2, 1, 2. All right, I believe that is it. So now we have our vertices and UVs set up. So now we can actually draw it on the screen now. So right over here, and we'll create a new mesh. So mesh equals new mesh. Going to pass in the vertices and then the UVs. Change verts to static. Awesome. Static. Static. So now we have the mesh created. So now we need shader equals new shader, and then pass in the file name. I called it default shader. And then after we clear the screen, but before we swap the buffers, we are going to bind the shader. So we're going to call shader.bind. Really? I didn't do that, did I? No. No, I didn't. Alright, I will do that here in just a second then. Stupid me. These episodes are going to be all screwed up, but I will get the hang of it sooner or later. So now we're going to set a uniform for the color. New color 0111. And I have two news in here. And apparently I forgot that too. So we will get to that as well. So after we set the uniforms, we're going to call mesh.render. And then after we render, we need to unbind the shader. So shader dot, we will call it unbind. Alright, so there's a few things we need to do here. And it looks like it's all in the shader class. So open up shader. And yes, I did. Completely ignored it. Alright. So I guess first thing we can do is just go ahead and set up the uniforms. So let's do void set uniform. And then whenever we set the uniform, we need the name of the uniform and then what it's actually, what type it is. So after we get that, then we need to cache the location. So we're going to call GL get uniform location and pass in the program and the name. So this will get the location of the uniform and then store it into this variable. We're going to check if the location even exists. So if the location does not equal 1, so if it exists, then we need to call GL uniform 4F. And then pass in the location. And then we're just going to say C.R, C.G, C.B, C.A. That way all the information is passed to the shader with the uniform that we specified if the location is actually there. So that fixes our uniform problem. Now we need public void bind. And you're always going to bind the shader and then unbind it whenever you're not using it. Public void unbind. I don't think I capitalized the B. And then we're going to use GL use program and then program. And then to unbind it, all we do is we GL use program and set it to 0. So that's the easy part about that. Alright, what kind of madness we got here? Okay, I did put a capital B. That's an easy fix. Alright, let's see how this works. It should be a square rendering somewhere, and default shader. Alright, so where is our path? Our path is... Oh, I put a dot in there, didn't I? Yeah, we don't need that dot. There we go. Now we have our square being rendered in some color. Now, since we have not done the matrices yet, it's in the standard coordinate systems. So 0 is right here in the middle. And then you have like -1 over here. You have +1 over here. Since we're drawing the quad at 0.5, it's doing half of it. Now we can change the color of this quad at any time. So we can go back to core and we will do blue. All right, and that changes it to blue. So next episode we will get into matrices and getting this to the coordinate system that we want it to be in. So like I said, we're going to be working on UI, so we're going to start from up here and then go all the way down here, which we set our window size to 800 by 600. So that corner right there will be 800 on the X, 600 on the Y. All right, thanks for watching, and I will see you next time.